This plot illustrates the climate behavior of planets in the runaway greenhouse phase. Now, the left-hand side shows the outgoing radiation versus the surface temperature of the planet. The magma ocean cooldown sequence would go from right to left. It is illustrated here for different volatiles, different surface pressures. For instance, a surface pressure of 260 bar corresponds to roughly 1 Earth ocean. And 1 bar is of course the present day surface pressure on Earth. Now, this shows you that varying the dominant volatile in the atmosphere and varying the surface pressure corresponds to orders of magnitude differences in heat loss of the planet, and therefore would suggest strongly varying cooling sequences of these planets. On the right-hand side, you see the net radiation to space, which means this also takes into account the incoming stellar radiation. There are two parts, a blue part and a red part. The blue part is corresponding to a potentially Earth-like installation, meaning that these planets can cool down. For the red part, these planets actually receive more energy from the star than they can radiate to space. This means they would be stuck in their runaway greenhouse phase until, for instance, loss process reduce the atmospheric budget such that these planets can begin to cool again. In the Earth science community or in the planetary science community, to illustrate this, there's a debate, for instance, whether this is an Earth-type evolution of the magma ocean, whereas this is actually the Venus-type evolution of magma ocean cooldown.